Alright, so hi guys, it's Javier and Kiam, your friendly neighborhood Asian here to teach about meniscus. So, meniscus comes from Greek meaning crescent or like curve. So, if you look at a meniscus, you can see the curvature. And a meniscus is caused by the upper surface of a liquid close to the surface of a container or another object, and this is caused by surface tension. So you see they're like the crescent shape. So, the way you read a meniscus is the very bottom portion of the meniscus, you're going to hold it eye level and you're going to look at it head on. The very bottom of the portion is going to be the reading. So it's not the top, so it's not going to be 45 milliliters, but it's going to be 40.
Evening, folks. I'm going to get 10 milliliters of our 20% solution and put it in our 25 milliliter flask. And then I'm going to put our 15 milliliters of water and also put it in that flask to dilute it.
We have Eli, who is getting that meniscus right up to that 25 milliliter mark.
So here I'm taking 10 milliliters of the 20% stock first initial of the concentration. So now we're going to put it here in the concentration flask. So we are going to the process of diluting. So we can find our next concentration of our liquid. Huh? Okay, so for finding our next concentration, we're gonna base it on the next formula that I'm gonna present in a few minutes. So we leave the 10 milliliters here and we're gonna dilute the rest with water. This formula, okay, which says the initial concentration times the initial volume that we're using, it's gonna be equal to the final concentration times the second volume, okay? For our first concentration, it's 20% stock, as I said before. And our first volume, it's going to be 10 milliliters that I take from the pipette. Okay, so we are looking for our second concentration, and we know that with our concentration flask, we're going to take 25 milliliters. So we leave the second concentration alone, and we take the product over here. Over 25 milliliters. Okay, so the product of our second concentration will be 8% stock. So after we finish diluting our concentration here in the concentration flask, we have an 8% sugar water. Our second concentration will be 8% stock. So here at the notes that I have here, we'll need to continue going down with the concentration. As we go down with the concentrations, we also need to take the mass, the volume, and its density. Here we can see that as the concentration goes down, also the density goes down.
All right, so, folks, we're gonna do a pants and/or body check.
Pants, closed-toe shoes, pants, closed-toe shoes.
So now we're gonna take the mass of this. First, we rate to 0 our balance, and then we put the solution here. With this concentration, it was 44.558. Okay, we'll take it from 19.636. That is the mass of the concentration flask. That would be 24.9.
Okay, so it's lower. Here we go.
Yeah, as we see over here, the lower the concentration, the mass reduces. It went from 27 all the way down to 24.9 grams. Okay, as the concentration is 1.28% stock. So we make our calculations from the density.
24.9 times 0.996. So
we can get to the conclusion that as the concentration lowers in the sugar solution, also the density does.